Hi, I'm Mahesh Tyagarajan with Kroger, and I'm a VP of Engineering. Uh, Today, we'll talk about the technology strategy and the transformation that's going on at Kroger. So Kroger was founded in 1883 in Cincinnati, Ohio, been around for a while. We are the largest supermarket in the US, and we are the second largest retailer in the US and the fifth largest in the world. Um, we have about 3,000 stores of various formats, fuel, jewelry, clinics, all of that. And we have about 18 chains or brands or banners. And uh, we've been uh, growing and uh, doing this through various consolidations. So you'll see a lot of these brands in your areas, which might not say Kroger, like Fred Meyer or Dillon's or Mariano's. Those are all part of the same family. Uh, we we we're also in the manufacturing side of things and the supply chain, and we have about 18 dairy plants, 9 bakeries, and 7 grocery plants. And all of this comes together in a supply chain and a delivery mechanism in a typical retail format. And that's really is the information behind uh, what drives the retail front itself. We do also have the digital channels that has been there for a little over 5 years now. So why are we doing this? We've been having an aging technology that we're working with. There are many point solutions that we need to rethink and see if we need to consolidate. We're going to have to address all of the things around scalability, availability, reliability, and observability. So monitoring and everything else that goes with it. Digital, which is really online, and then you can either pick up or have it delivered or have things shipped to you, has been the largest growing channels traffic-wise, and especially with COVID-19, we saw an enormous increase in the traffic, and the patterns of shopping have shifted to our digital channels. And so those also are leading to convergence because, like I mentioned, you can order online and go pick up in a store. So there's always a physical component associated with the e-commerce aspects of the digital that we do. And there's delivery, there's shipment. There's also different ways we fulfill, which is to say that we can fulfill from a store or a shed or a dark store, and those we call modalities, and they all come together to actually make your order come to life. And when there's this kind of interplay between digital and physical, there's always a lot of technology systems that need to come together to work well together. And that's really why we're in this really transformation of the technology stack that we have. So what are we doing? We're doing a tech refresh based on cloud and SOA microservices. So that is kind of the bedrock for what we're doing. We're not just lifting and shifting. Certain things certain workloads we might have to lift and shift, but we're certainly doing a lot of rewrite when appropriate and going to a microservices architecture. We will always be hybrid. There will be workload on-prem and even at the edge on the store and in clouds, and we'll have it in 1 or 2 public clouds. We anticipate a few hundreds of microservices and also service back experiences, which is like experience as a service or UI as a service, which is to say it is highly componentized, and we're actually bringing business functionality together based on the componentization. And that allows us to drive the velocity of business functionality we can bring to bear. We're redoing this to be highly scalable. One of the things that we want is the scale. And for that reason, we're going through this whole non-functional ability review in addition to the functional side of things. Our focus has been on APIs and frameworks, and a little bit about how we're thinking about the problem. A lot of what we're trying to do is with open source, and when that's not an option, we'll look at other options, but open source, but commercial open source, which is like there's a commercial backing to that open source. We find that open source has a huge community. We can benefit from it. We cannot hire as many people as the entire open source community has. Also, we find the rigor in which the open source packages are looked at, tested, mature much faster, and allows us to also make use of upgrades and go through that cycle of upgrades without, of course, we'll pay for the commercial aspects of the open source, but certainly the new functionality or the upgrades we would like to be able to make use of as they become available. So a big part of our focus has been to look at open source in addition to any of the package software that's available out there. This is our technology stack as of now. It will look like any typical cloud platform, but let me focus on the data stores aspect of it. We're using Gigabyte. Amongst other data stores, we're using Elastic, Mongo, Redis, Cosmos DB. But we'll spend quite a bit of time in the next few slides around Gigabyte, our choices around Gigabyte for our workloads and how we came about that. So why Gigabyte? And what does it give us? So we chose Gigabyte mainly because it gives us these following things, right? It gives us multiple API compatibility, which means we can access it through YSQL or YCQL because we have both the Postgres and the Cassandra-like workloads. We're certainly looking at a distributed asset requirement set across multiple transactional aspects of our systems. We're wanting to be in multiple regions for all the reasons that one could think of. So we're looking at multi-master and or active-active. That gives us the ability to be able to be always available and all of those kinds of things, the other non-functional abilities. Scalability was a huge factor in determining some of the reasons why we were going with Gigabyte. We wanted to be horizontally scalable. We also wanted to make sure that auto sharding was taken care of so that the application need not deal with the sharding. And we also looked at fault tolerance and recovery aspects. So a lot of this went into a thought process to make sure that we were picking the right solutions. And in all of this, we spent quite a bit of time, maybe 6 to 9 months, testing this out before we went down the path to convince ourselves that all of this was available and it was meeting our goals. So stepping into the deployment topologies and findings. So we're using two topologies. One, of course, is like the geo-distributed, and there is like three regions that look like a single cluster. And then there's sharding between those regions and this data that's moving around in between the shards. It's the writes happen and it'll happen to multiple of those regions before it returns. So that's one aspect of it. We're doing that for all the transactional data and all the things that are where there's money involved, whatever else. Card checkout are good examples over there. And we're also doing it in a different fashion where it looks like that. It looks like that three region thing, but it's within one region, right? So it's one cluster, and then it replicates to another cluster. So even though you could have and that's the right side of the slide over here, and we have an asynchronous replication between the two clusters, which for us are in two separate regions. And we can have, it's active, but we're geo affinity based. So the users will end up in one or the other based on their geo. And highly unlikely, but it might happen, highly unlikely that they will ping pong. And so that allows us to do some of those things in that clustered replication as well as clustered asynchronous replication. So that's pretty much how we're using it. And a shopping list is a good example of that second async replication mechanism. We've been really pleased with the outcomes. We've had low latency. We've been looking at the fault tolerance aspects. The latencies have been at the data tier has been like in the single digit milliseconds. So that's been great. Really looking at this point to expand on our use cases based on all that we have going with our use right now. We're also looking for additional product offerings from Gigabyte. One of the aspects is the Gigabyte platform that is available in GCP. We're looking for that to become available in Azure. We're deployed both in GCP and in Azure. And while currently we can treat our Azure deployments as similar to on-prem deployments, but we'd like to see the level of automation and the manageability that the Gigabyte platform provides on GCP available in Azure. So that's one thing we're looking at. The second aspect of this is change data capture. We have certain specific requirements for change data capture, and we're actually looking to utilize that mechanism to drives some of our replication, some of our data movement between one use case and another, and in some cases between one cloud and another. So we're looking at all of these as possible future product offerings that are going to help us quite a bit. So that pretty much wraps up my part of the discussion, and I'm open to questions at this